In our next set of polynomial inequality, or inequality examples, we're going to talk about polynomials, and the way that we solve polynomial inequalities is by using something called a critical number method. Essentially, the critical number method is a way of solving inequalities by taking advantage of the rules that tell us that if we have two numbers multiplied, whenever they are equal to 0, we can use those points to divide where the entire expression could be either positive or negative. Let me show you a basic example using x squared minus 5x is greater than 0. First and foremost in this method, the inequality must be set to 0. So we must be set to 0 to make this work. Very important. Okay. So we must be set to 0, and of course we are in this one. So we factor. We always start by factoring. Set to 0. Number 2, factor. All right, so we're going to factor our expression. We've got x times the quantity x minus 5 is greater than 0. Now the next step is one that people tend to forget, so you do have to be careful. Set both factors to 0 to find your critical numbers. Set both factors to 0 to find critical numbers, and we're going to plot these on the number line. So I'm going to make up my number line right here. On my number line, I have 0, 1, 2, 3, 4, and 5. Here's a number to the right, here's a number to the left. And since these are our critical numbers, one really fast way of getting this is to remember that what we're looking for are all the results that are going to be positive. When a number is greater than 0, it's positive. So our product consists of x multiplied by x minus 5. And so we'll note, x is always negative when we're to the left of 0. And it's always a positive number when we're to the right. This is called a sine graph, S-I-G-N graph. All we're doing is we're taking each linear factor and finding out where it changes from negative to positive. And for the second factor, x minus 5, that happens when x turns into 5. So we've got negatives for the quantity x minus 5 for each number that we can substitute in for x less than 5, and a positive number for every value to the right. Now remembering that we're multiplying x times x minus 5, we're going to say negative times a negative gives me a positive times a negative gives me a negative, and a positive times a positive gives me a positive. We're interested in the numbers that are greater than 0, which means positive, and so right over our number line, wherever we have positive, we can highlight that area, and we see that our solution set is going to consist of two pieces. We're going to have a piece that goes from negative infinity to 0. We're going to join that with the other piece by a union that goes from 5 to positive infinity. Okay, so the critical number method basically tells us to find the place on the axis where the polynomial set to 0 is actually equal to 0, and we use a sine graph in order to get the solution set itself. So let's try this with the second one. Our first job would be able to set the whole thing to 0. So the first thing we're going to have to do is we're going to have to gather all of our terms, and we gather to the left-hand side. So we're going to move here by adding 2x and subtracting 6 from both sides. Well, x squared doesn't change, it has no like terms, but negative 3x, we add 2x, we get negative 1x. And positive 6 on the left-hand side would be subtracted to be minus 6. And so we get the quantity x squared minus x minus 6 is less than or equal to 0. Well, x squared minus x minus 6 factors as two binomials, x times x, and of course 6 is divisible as either 6 and 1 or 3 and 2. Well, we're going to have negative 3 and positive 2 here, because negative 3 times positive 2 gives us negative 6, and negative 3x plus 2x gives us negative 1x, our middle term. So we've got our factored form, and that gives us our two critical numbers set to 0. So our critical numbers are at x equals -2 and x equals 3. So on our number line, we're going to go ahead and plot those. So I go over here to -2, and go over here to +3, and the quantity x plus 2 is going to be a quantity that is negative for all numbers to the left of -2. If you put in -3, for example, you get a negative number. And for all numbers to the right, it's a positive value. For the quantity x minus 3, all numbers to the left of +3 are going to make that factor negative, and all numbers to the right of +3, if we put in +4, for example, we're going to get a positive number as a result. Now we're multiplying both factors, so we're going to get a positive set of values for all numbers to the left of -2. We're going to get a negative set of values for all numbers between -2 and 3, and a positive set of numbers for all numbers between -2 and +3. We want the ones that are less than 0, which means that we want our negative value. So we're going to use some square brackets. Remember, we're using less than or equal to. So we're going to use square brackets to include our endpoints, and in this case we include -2 and +3, and so our solution set is going to be the set from -2 with a square bracket all the way up to +3. That's our solution set, and so we're done.